Aero Gear Company is among the world's top producers of precision gears. Throughout all areas of our company, we have integrated the latest technologies and are equipped with the most advanced machining capabilities. But our expertise is more extensive than the actual process of machining gears. Resulting from our history of over 50 years in the gear business, we not only understand how to manufacture gears, but also how to engineer them to ensure peak performance and create cost savings for our customers. In this program, we'd like to provide more information on our extensive expertise in the area of gear design. A critical attribute of a gear's design is its contact pattern. Simply stated, the contact pattern is the area in which the gear teeth come in contact with each other as the gears rotate. This area of contact is easily checked in this way. The teeth are coated with a special marking compound and then run together in a tester. Tape is then applied to the tooth surface and transferred to a piece of paper. Looking at the tape transfer, we can see the area of the gear tooth that is in contact, and this is what we refer to as the contact pattern. When a gear is installed in a gearbox and is actually powering the designated application, there are varying degrees of pressure or load on the gear teeth. When the gear teeth are under load, the contact pattern will change. Here we see a contact pattern from a gear with a very light load. And here is a contact pattern from the same gear with a very heavy load. So there is a general rule of thumb which states that the heavier the load, the larger the contact pattern. Now here is where the issue of contact pattern becomes so important. For a gear to perform properly under load, the contact pattern must be a certain shape and at a certain location. Typically, an ideal tooth contact pattern should be this type of oval shape and be located in this area, which is referred to as being located centrally to the toe of the gear tooth. While this may seem simple, it is a rather complicated subject, although one that Aero Gear is very knowledgeable in. There is another critical issue to consider when assessing how the contact pattern will perform in an operating gearbox. This issue is gear displacement. In the operation of many gearboxes, the gears and their shafts do not remain in a fixed orientation. Due to thermal forces and stress from being under load, the components of the gearbox will actually move from their axes. There are typically 4 different types of movement which can take place, and these movements are described as offset, pinion in and out of mesh, gear in and out of mesh, and shaft angle. It is this movement that is referred to as gear displacement, and it can occur in any combination of the 4 types. In aerospace gearboxes, where keeping weight to a minimum is a high priority, the mass of the gearing used is usually lighter, and these displacements can be significant. On the other hand, in commercial applications where the gearbox components are typically more rigid, there is not the same degree of displacement. The size and position of the contact pattern has always been a primary design consideration for gears, and for many years achieving a good contact pattern was performed through the same methods that the vast majority of gear producers still use today. The conventional method of achieving an ideal contact pattern is performed in this way. First, an engineer will make an educated guess at how the gear should be made so that the contact pattern will be correct. Next, the part is fabricated and the gear teeth are machined. When the gear and its mating part are finished, they are run together in a tester. More often than not, the contact pattern will not be correct in this first attempt, and this requires going back and changing the settings on the gear tooth cutter and grinder, then producing a new gear and pinion. The parts are checked again. This trial and error process can continue through many cycles until the best educated guess for contact pattern location is achieved. But how will the gear perform under load in a gearbox, and what will the contact pattern look like then? This leads to more steps in the trial and error process. First, the gears must be mounted in the gearbox and run at operating speed and load. Then the gears are visually inspected to check the contact pattern, which is indicated by the wear pattern on the mating tooth surfaces. If the pattern is not correct, which is commonly the case, it's back to the tooth cutting and grinding machines, where settings changes must be made, new gears must be produced, and the cycle continues. For a new gear design, this process can take up to 6 months or more to complete. And while this is a time-consuming and costly process, it was just the way it had to be done, or it was until recently. To see how Arrow has eliminated the need for this costly trial and error method of contact pattern development, please proceed to the next chapter. In keeping with Arrow's goal of being among the most technologically advanced gear producers, we have implemented a highly advanced system for performing contact pattern development, a system that provides a dramatic reduction in the time and expense of the process when compared to conventional methods. This system uses a combination of state-of-the-art development software and machine tools. Among its key components are Gleason's G-Age, Cage, Mini Gauge, Loaded TCA, and Finite Element Analysis software packages. And for machine tools, Arrow uses Gleason Phoenix CNC tooth cutters and Phoenix CNC tooth grinders in conjunction with a Zeiss Hoffler CNC gear inspection system. More detailed information on the use of this system will follow, but here are a few highlights of its capabilities. Using the development software, Arrow engineers can build virtual models to predict how the gear will perform in actual operation. This in turn generates the settings to be used by the machine tools. In addition, these settings for the machine adjustments are automatically downloaded to the machine tools, greatly reducing the time spent on setup. And here's the dramatic part. Ideal settings of the machine tools, which are required to produce the desired contact pattern, are typically achieved in the first or second attempt. This system eliminates the trial and error process that was once required, and the bottom line is that development time is reduced and Arrow's customers save money. An interesting footnote on this system is that Arrow was the first gear company in the world to utilize this type of comprehensive or closed-loop system. And today, only Arrow Gear and Gleason have this system under one roof. This is clearly a testimony of Arrow's competitive edge resulting from the use of advanced technology.